Hi everyone, this is regarding Big Data Analytics and Applications Project Group 4, and I'm Charan. I'll be walking you through this whole project. My other teammates are Siva, Buddi and Rohita, Goparaju. So our project is about demonstrating the impact of news articles by news archives on the stocks and how news archives and stocks would be impacting different ways of um, selling or buying the stock prices. So, from our research, from our hypothesis, we believe that there is a segment of change in the stock prices looking at the news data. While the news can be captured from multiple sources, that can be an opinion from a celebrity or a buying or selling aspect from this famous stock management portfolio owners or any such reasons. Most of them are usually captured in news. So we try to understand those news sentiments and see based on that whether the stock prices would be rising or falling. So in order to do this, we proposed a multimodal approach where the first part of this problem is solved by using the news archives we found from the Kaggle. So our project is a convergence of two data sets, which is Kaggle dataset for news archives and another data set for the stock prices. Let's go into the details. Well, I have here all my data is currently present in here, and these are the sentimental data that I used for the processing the data. This is based on the some financial data set, which helps me to train the models, and so that models are ready for the prediction on the actual data. These are based on the financial terms. As we see here, these are the financial standards. Now, getting back to the other data, this is a news archive. The news archive that we see is based on that. This is, for example, talking why, what's happening to in shares of Chinese electrical market. That's how this article is talking about. So our goal is to identify sentiments for this industry, NIO, as part of that news article. So the first part of this problem is to sort out and to gather the important points from the data so that we don't use a lot of data. So the first one is a summarization model. Here is a code for the summarization model. I will run this up to show it's running, but I will not finish this because this takes some time to finish it. As we can see, it's currently processing the data, and once we have the data based on the content, it just processes the data and finds us it. So once I'm stopping this run in order to demonstrate other models, and once this is done, I get the processed data with the summary. This is the news with summary data, and if I see this CSV, you can see the summary here. You can see the summary generated here. This is in fact a very compact version of the original content, which helps us to evaluate the context within this whole content so as to identify sentiments correctly. So what happens in a bigger, larger scale is firstly we face the vanishing gradients issue, because if the sentence is too long or there are limitations of how much data we can take into one input of run into the model. So that's why we had another second model called Finbert, which is customized from the transformer based model. So this model has been retrained, taken the example of the earlier BERT model, which is trained from the Wikipedia. This model is now changed, modified to add more layers in order to bring the sentiment analysis for us. The model can be seen in here. As we see, these are the new set of layers that's been added in order to help us sort out the classification problem from the original BERT model. So this is itself is a very customized model in order to make sure our classification works. So since the model is huge, I came across multiple issues in terms of seeing the data, and so I had to use the models in order to give the batch size to a limited size like 4 or 8 based on the training and the testing. So once after these model runs, which can be triggered from here, as I can show you, once this model gets running, as we can see, it's starting to load and start to train. I'm stopping this because of the huge amount of time again it takes. So once that is done, it gets the sentimental data generated, and these sentiments are generated, and using this sentiment data and the stocks price that we have managed to process them and lead them into a converged data set, which can be seen here as a link shared in the code as well for the reference, and plots can be seen here as a final reference. So once this data is arrived, then we can see a run of LST models and the ARIMA models. ARIMA is a statistical model for the time series analysis, which does the generation and sees of how closure the value gets. But we prefer to have neural networks because they tend to learn with time. So we used an LSTM model to identify and understand how the values come across. So on that comparison, as we can see, once the data is arrived, we made the comparison between two data, that is sentiment data and the financial data. As we can see here, we can see the plots are being generated. So let me take a quick example of a single plot which explains. So these are the sentiments. So you can see there's a sharp rise in sentiments. This is a sequence ID. So in the sequence of 2020, and you see there's a sharp increase in the price of the record. And thereon, it was neutral. The sentiments afterwards is neutral. It's not negative. So it stayed on. So at this point, when it's reducing, you could see the patterns following. Although it's not 100% accurate to meet all of the amount, but the majority of the cases, we can see the data follows, the news data strictly follows based on how well sentiments are being raised or fallen. As we can see, the most of the sentiments here are positive and neutral. So this graph kept increasing, but here once it's failing, and you could see the same sharp fall in the stock prices as well. There is an important point to note that we see these data, news article comes first and then the stock prices ends later. Thank you very much.